Welcome back, Calc students. This is Tutorial 3 for Exponential Functions, Section 1.3. Now, we just went over some applications with growth and decay, and now we're going to do some banking problems. Let's take a look at the personal banking, and here I have A equals, and I should have put a P right there, parentheses 1 plus R over N raised to the NT. So let's just review some of these variables. A is going to be the amount, P is going to be the principal, and principal is going to be how much money you invested into the bank. R is going to be the rate, and N is going to be compound interest, and T is going to be time. Now, what I mean by compound interest is you could compound your account annually, which means N would be 1. Monthly, which means every end of the month, it'd be 12 times out of the year. You could do it quarterly, 4 times out of the year. You could also do it daily, which is 365. We're going to take a look at these in the next example below. Let's just say you have $5,000. Maybe for graduation party, that's what you ended up with. Grandma was pretty generous. And you're going to invest this money at a very good rate, 4.5, and we're going to compound it annually. And I didn't give a year, so let's just say it's 1 year. Let's just assume that T is 1. So we're going to use our equation, 5,000, and it's 1 plus 0.045 is your rate, and we're first going to do annual. And like I said, it's going to be the year is going to be for 1 year. We're going to do this. I'm just going to put that right here. Time is 1 year. And I already did the calculations to save time on our video. When you guys plug this in the calculator, you're going to end up with $5,225. It's not bad for 1 year. Letting that money sit in the bank, and at the end of the year, you collect $225 for doing nothing, just letting the bank collect the interest on it. Let's go ahead and do this for monthly. If I was to do it monthly, it'd be 1 plus 0.045. Monthly is going to be divided by 12, and then 1 times 12 in the exponent. And again, just for convenience here, you're going to end up with $5,229.70. So it's a little better. It's a little better. If you can find a bank that's going to compound it monthly, that's going to be better than annual. Let's do daily. And 0.045 divided by 365. Raise it to the 365 times 1. And that's the best right here is 5,230.12. So this is how you're going to apply simple interest type problems, principal, rate, the compound interest, and then the time. Now, 365, if you're going to compound this daily, at the end of the day, that's what you're going to reinvest. You're going to keep putting your money back in, or you're keeping the interest, let it grow. What if we decide to do it hourly, or better yet, minutes, every second, about every moment of the day that you're going to compound this money in the bank, and that gives us an equation, PERT. And I'm hoping all of this is familiar. PERT, E is this natural number. I think you may have talked about it before, and I can talk to you why it is that way when you come into school. But this is the equation where it's going to be compound continuously. So if you're going to compound it continuously, you're going to use this equation. And if you plug it into the, let's see, our example here is 5,000, E raised to 0.045, and T was 1, right? That was 1 year. And if you plug it into the calculator, I'm going to go ahead and throw this in here. You're going to get 5,230, and I'm going to raise it to 14 cents. So it's a little better, compounded continuously. Okay, so let's take a look at an example. Determine how much time it would take for your money to triple when it's compounded continuously. So I'll start out with PERT. And let's go ahead and use this example of 5,000 e to the 0.045 is our rate as before, and it's asking how much time. So I'll put a T here, and they want to know when it's going to be compounded. Can you say, oh, tripled, when your money is tripled. So this would be 15,000. Now you're going to have to solve for T. Graphically, the book is probably going to ask you to do it graphically. Later on, I'm going to show you how to do it algebraically. Just to kind of clean this up, though. Well, let's see here. I'm just going to divide by 5,000 right away to get 3 equals e to the 0.045 t. That's going to be a little bit easier. I'm going to skip all the steps as far as graphing it and showing on the video. But you should get an answer. Oops, let me try this again here. 24.4 years for your money to triple. Again, this is probably the book kind of wants you just to do a graphic approach of solving, and if you know how to solve it through logs, you can go ahead and do that, but I won't teach that until we get to that section. All right, I'm going to conclude this example, this tutorial, and I'll bring up the next one with exponential regression, and I will see you then.